Sydney wakes slowly before sunrise. Streetlights glow, buses move through quiet roads, and the first trains begin carrying workers toward the city. From the air, the skyline looks calm, but beneath the surface, the pressure of a growing population is felt every day. Sydney is one of the fastest-growing cities in Australia, and as the population increased, the transport system that once worked well began to struggle. Platforms became crowded, highways filled with traffic, and daily travel times grew longer. Engineers, planners, and city leaders began to realize that the future of Sydney depended on building something completely new. The idea was not just to add more buses or extend old railway lines. The city needed a modern system designed for the next 50 years, not just the next 5. That idea became Sydney Metro, a fully automated driverless train network designed to move people faster, more safely, and more efficiently than traditional rail. It would run frequently, reduce congestion, and connect new suburbs to the heart of the city. But imagining a metro system is easy. Building one beneath a busy, living city is one of the most difficult engineering challenges in the world. Before construction could begin, engineers spent years studying the ground. They drilled deep boreholes, collected rock samples, and mapped layers of sandstone that had formed millions of years ago. They studied groundwater levels, underground utilities, and the foundations of existing buildings. Every tunnel route had to be carefully planned, because even a small mistake underground can cause serious damage above the surface. Survey teams worked day and night, measuring, calculating, and planning routes with extreme precision. When construction finally began, some of the most powerful machines ever used in Australia arrived on site. Tunnel boring machines, often called TBMS, were transported in massive sections and assembled deep underground. These machines are enormous, sometimes longer than a football field, and weigh thousands of tons. At the front is a rotating cutter head that slowly grinds through rock, while behind it conveyor systems carry debris away, and robotic arms install concrete tunnel segments to form the tunnel walls. The process moves slowly but continuously, sometimes advancing only a few meters per day, but it operates with incredible accuracy. Deep underground, conditions are very different from the world above. The air is humid, the sound of machinery echoes through the tunnels, and the only light comes from industrial lamps attached to the walls. Workers wear helmets, reflective clothing, and protective equipment as they guide machinery, monitor instruments, and ensure every segment is installed perfectly. Safety is always the highest priority, because underground construction leaves little room for error. While tunnels were being excavated, another team worked on building stations. Station construction is often even more complex than tunneling, because stations are large underground structures that must support heavy loads from the streets and buildings above. Engineers built deep excavation pits, sometimes more than 20 or 30 meters below ground level. Massive steel reinforcement cages were installed, and thousands of cubic meters of concrete were poured to create strong foundations and walls. Above ground, Sydney continued its daily life. Traffic moved, shops opened, and people walked past construction sites, often unaware of the massive work happening beneath their feet. One of the biggest challenges of the project was minimizing disruption. Construction teams worked carefully to reduce noise, control dust, and maintain access to roads and businesses. In some areas, work took place at night to avoid disturbing the city during busy hours. As tunnels extended further, rails began to be installed. Rail installation is a precise process. First, concrete bases are prepared and leveled with extreme accuracy. Then sleepers are placed, rails are aligned, and fastening systems secure everything in place. Even a few millimeters of misalignment can affect the smooth operation of trains, so engineers use laser measurement tools and digital monitoring systems to ensure perfect positioning. But tracks alone do not make a metro system. Behind the walls and ceilings of tunnels and stations lies a hidden network of systems that passengers never see. Electrical cables supply power to trains. Ventilation systems control air quality and temperature. Drainage systems remove water. Communication systems allow operators to monitor trains in real time. Fire safety systems are installed to protect passengers in emergencies. Each of these systems must work perfectly, because a metro is not just transportation. It is a complex machine spread across kilometers of tunnels and stations. One of the most advanced features of Sydney Metro is that the trains are fully automated. There is no driver in the traditional sense. Instead, trains are controlled by computer systems that monitor speed, distance, and track conditions every second. This allows trains to run more frequently and safely, reducing waiting times for passengers. Control centers staffed by trained operators oversee the entire network, watching screens that display the position and performance of every train in real time. Testing is one of the longest and most critical phases of any metro project. Before passengers are allowed to ride, trains must run thousands of kilometers in trial operations. Engineers test braking systems, signaling, doors, ventilation, and emergency procedures. They simulate power failures and emergency scenarios to ensure the system responds correctly. Every component must meet strict safety standards before approval is given. As construction progressed, the first sections of Sydney Metro began to open. For passengers, the experience felt different from traditional trains. Stations were modern, bright, and spacious. Platform screen doors added safety by separating passengers from tracks. Digital displays provided clear information, and trains arrived frequently, reducing the need to check schedules. What had once been a long and crowded commute became faster and more predictable. But Sydney Metro is more than just a transport system. It is reshaping how the city grows. New residential areas are developing near stations. Businesses are moving closer to transport hubs. Property values are changing, and new communities are forming around metro corridors. Infrastructure does not just move people, it shapes the future of cities. Even today, construction continues on new lines and extensions. Engineers and workers continue to dig tunnels, build stations, and expand the network. The work is slow, complex, and expensive, but its impact will last for generations. Projects like Sydney Metro are built not only for the people living in the city today, but for millions who will live there in the future. And perhaps the most remarkable thing is this. Every day, thousands of people ride the metro, often without thinking about the years of planning, the kilometers of tunnels, and the thousands of workers who made it possible. Beneath the quiet platforms and smooth-running trains lies one of the largest engineering efforts in Australia's history, a hidden world of concrete, steel, and precision that keeps the city moving. As the first tunnels of Sydney Metro pushed deeper beneath the city, engineers began to face challenges that could not be seen from the surface. Underground construction is never predictable. Every few meters, the ground can change. Hard sandstone can suddenly give way to softer layers. Water can appear in unexpected places. Even small geological variations can slow progress or force teams to redesign sections of the tunnel. Tunnel boring machines moved forward slowly, sometimes only a few meters each day. The cutter head rotated constantly, grinding rock into fragments while conveyor systems carried the material away. The process looked powerful, but in reality it required patience and precision. Every segment of concrete installed behind the machine had to fit perfectly. Workers monitored pressure, alignment, and vibration at all times, because even a slight imbalance could affect the structure of the tunnel. One of the greatest risks in tunneling beneath a city is ground movement. Buildings, roads, and utilities above depend on stable soil. Engineers installed hundreds of monitoring points across the city to measure movement in millimeters. Sensors were placed on buildings, roads, and even underground pipelines. If any movement was detected beyond safe limits, work would slow or stop until engineers understood the cause. This level of monitoring allowed construction to continue safely, even in sensitive urban areas. Another challenge was water. In some areas, groundwater seeped into excavations and tunnels. Pumps worked continuously to remove water and keep the construction environment dry. Waterproof membranes were installed to prevent long-term leaks, and drainage systems were designed to carry water away safely. Underground infrastructure must remain stable for decades, so protecting tunnels from moisture was critical. Heat and ventilation were also major concerns. Deep underground, fresh air does not circulate naturally. Large ventilation systems were installed to move air through tunnels and construction areas. These systems removed dust, controlled temperature, and ensured safe oxygen levels for workers. The sound of ventilation fans became part of daily life underground, echoing through long tunnel passages. At the same time, Above ground, station construction continued at full speed. Some stations required excavation pits so large that entire city blocks appeared transformed. Massive retaining walls were built to support surrounding soil, and heavy cranes moved steel reinforcement and concrete into place. From the street, pedestrians could see only barriers and machinery, but below those barriers, enormous underground halls were taking shape. Stations are not just platforms and tracks. They are complex structures with multiple levels, including concourses, escalators, ventilation rooms, electrical rooms, and emergency exits. Engineers had to design these spaces to handle thousands of passengers every hour while maintaining safety and comfort. Fire protection systems, smoke extraction systems, and emergency lighting were carefully integrated into every design. As tunnels and stations advanced, another phase of work began, installing the systems that would bring the railway to life. Electrical cables stretched for kilometers through tunnels, carrying power to trains and station equipment. Communication systems were installed to allow constant contact between trains and control centers. Signal systems were calibrated with extreme precision because automated trains depend entirely on digital control to operate safely. Testing these systems required months of careful work. Engineers checked every connection, every sensor, and every control panel. Even small faults could cause delays or safety risks, so inspections were detailed and repeated many times. The goal was not just to make the system work, but to make it reliable for decades of daily operation. One of the most fascinating aspects of Sydney Metro is its driverless technology. Unlike traditional trains, these trains operate automatically, controlled by advanced computer systems. Sensors monitor speed and distance continuously, ensuring trains maintain safe spacing from each other. Doors open and close automatically, and control centers supervise operations in real time. This technology allows trains to run more frequently, reducing waiting times and improving efficiency. Before passengers ever stepped on board, trains ran thousands of kilometers in testing. Engineers simulated emergency situations, power interruptions, and system failures to ensure every scenario could be handled safely. These tests often took place at night, when tunnels were quiet and the city above was asleep. Inside the control rooms, operators watched screens filled with data, carefully observing how the system responded. Construction of large infrastructure projects also brings logistical challenges. Thousands of workers, hundreds of machines, and constant deliveries of materials must be coordinated every day. Concrete, steel, electrical equipment, and mechanical systems arrived on tight schedules. Any delay in one part of the supply chain could slow progress across the entire project. Careful planning and communication were essential to keep work moving forward. Weather sometimes created unexpected difficulties. Heavy rain could flood excavation sites. Strong winds could delay crane operations. Even extreme heat affected workers and machinery. Construction teams adapted to these conditions, adjusting schedules and safety procedures to maintain progress without compromising safety. Despite all these challenges, progress continued. Slowly, tunnels connected, stations took shape, and sections of track were completed. Workers who had spent years underground began to see the results of their efforts. Empty tunnels became finished railway lines. Dark construction areas transformed into bright, modern stations. For many workers, the project was more than just a job. It was an opportunity to be part of something historic, something that would change the way millions of people move through their city. The scale of the work created a sense of pride and responsibility. Every bolt tightened, every cable installed, every measurement checked contributed to a system that would serve future generations. As the first sections of the metro prepared to open, attention turned to passengers. Stations were cleaned, signs installed, and final inspections completed. Safety officers walked through tunnels and platforms, checking emergency systems and evacuation routes. Everything had to be ready, because once passengers arrived, the system would need to operate smoothly from the very first day. When the first trains began carrying passengers, many people were surprised by how quiet and smooth the journey felt. Trains accelerated quickly, stations were bright and modern, and travel times were shorter than expected. What had once been long and stressful commutes became faster and more comfortable journeys. But the story of Sydney Metro was far from finished. New lines were already under construction, including tunnels beneath the harbor and through the heart of the city. Each new extension brought new engineering challenges, new risks, and new opportunities to improve how Sydney moves. Infrastructure projects of this scale take years to complete, but their impact lasts for generations. Roads wear out, buildings change, but underground railways often serve cities for more than a century. Engineers working on Sydney Metro were not just building tunnels and stations, they were building part of the city's future. And deep beneath the streets, long after passengers return home and the city grows quiet, maintenance crews continue their work. They inspect rails, check systems, and ensure everything remains ready for the next morning. Because a metro system never truly sleeps, it rests only for a few hours before the city wakes again. As more sections of Sydney Metro began operating, the impact on the city started to become visible. Commuters who once spent long hours in traffic found faster and more reliable ways to travel. Suburbs that once felt far from the city suddenly became connected. Travel times shortened, and daily routines began to change. What had once been considered distant neighborhoods were now only minutes away by metro. Transport systems do more than move people. They shape how cities grow. Around new metro stations, construction of apartments, offices, and shopping areas began to increase. Businesses moved closer to transport hubs, and new communities formed along the metro corridor. Urban planners often say that transport lines become the backbone of a city, guiding where development happens for decades. Sydney Metro was already beginning to reshape the city's future. But building and expanding such a system requires enormous investment. Large infrastructure projects cost billions of dollars, and Sydney Metro is no exception. Tunnels, stations, trains, electrical systems, and land acquisitions all contribute to the total cost. Some people questioned whether such spending was justified. Engineers and planners explained that infrastructure must be measured not only in cost, but in long-term value. Reduced congestion, shorter travel times, lower pollution, and economic growth can benefit a city for generations. One of the most ambitious phases of the project involved tunneling beneath Sydney Harbour and the crowded city centre. This was one of the most technically challenging parts of the entire network. The tunnels had to pass deep underground, avoiding existing foundations, utilities, and older rail tunnels. Precision was critical. Tunnel boring machines advanced slowly, guided by advanced navigation systems to ensure they remained exactly on course. Deep underground, the conditions were intense. The sound of machinery echoed through the tunnels, and the air carried the smell of rock dust and damp earth. Workers operated in shifts, ensuring progress continued day and night. Lighting illuminated the tunnel walls, and the steady rhythm of the machines became part of daily life for those working below the city. At the same time, above ground, massive station boxes were being constructed in some of the busiest parts of Sydney. Roads were carefully redirected, utilities were relocated, and excavation began in tightly controlled environments. Engineers designed support systems to ensure surrounding buildings remained stable. Every stage required careful planning and constant monitoring. As construction moved forward, attention also focused on sustainability. Modern metro systems are designed to be energy efficient and environmentally friendly. Electric trains produce fewer emissions compared to cars, helping reduce pollution in growing cities. Efficient braking systems allow trains to recover energy and return it to the power grid. Stations were designed with ventilation, lighting, and materials that reduce long-term energy consumption. Another important aspect of Sydney Metro is accessibility. Stations were designed to be easy to use for everyone, including elderly passengers, people with disabilities, and families with children. Elevators, clear signage, wide platforms, and step-free access were integrated into every station. Modern transport systems are not just about speed, they are about comfort, safety, and inclusiveness. Technology continues to play a major role in the metro's operation. Control centers monitor every train, track condition, and system performance in real time. Advanced sensors detect issues before they become problems. Maintenance teams use digital data to predict when equipment needs servicing, reducing the risk of unexpected failures. This approach, often called predictive maintenance, helps keep the system running smoothly. Late at night, when the last trains stop running, Another world comes alive inside the tunnels. Maintenance crews enter the tracks, inspecting rails, checking cables, and cleaning equipment. Specialized vehicles move slowly through the tunnels, carrying tools and spare parts. These quiet hours are essential, ensuring that the system is ready for the morning rush. Looking to the future, Sydney Metro is planned to continue expanding. New lines and extensions will connect more suburbs, airports, and business districts. Each new section will bring new engineering challenges, but also new opportunities. Cities never stop growing, and transport networks must grow with them. Many experts believe that automated metro systems represent the future of urban transport. Driverless trains can run more frequently, reduce operational costs, and improve reliability. As technology continues to improve, systems like Sydney Metro may become even more advanced, with smarter controls, better energy efficiency, and improved passenger experience. For the people who worked on the project, the Metro represents years of effort, planning, and teamwork. Thousands of engineers, construction workers, electricians, planners, and technicians contributed to building the system. Many spent years working underground or on construction sites, often in difficult conditions, to bring the project to life. Passengers who travel on the metro today may not see the tunnels deep beneath their feet or the complex systems hidden behind walls and ceilings. They may not think about the machines that carved through rock, the workers who installed every cable, or the engineers who designed every detail. But every smooth journey is the result of countless hours of work and careful planning. Infrastructure projects like Sydney Metro remind us that cities are always evolving. Beneath the busy streets and shining skylines, there are networks of tunnels, pipes, cables, and foundations that keep everything running. These hidden systems are the quiet engines of modern life. As the sun sets over Sydney and the last trains of the day carry passengers home, the city begins to slow. Lights reflect on the harbor, traffic becomes lighter, and stations grow quiet. But deep underground, the metro waits, ready to begin again in the morning. Because a great city never truly stops moving. And perhaps that is the real story of Sydney Metro. It is not just a railway. It is a symbol of how cities prepare for the future, how engineers solve complex problems, and how millions of people depend every day on structures they rarely see, but could never live without.